I am Manish Karandi. I am going to explain the 3-phase half controller rectifier. Here we can see the circuit diagram of 3-phase half controller rectifier. The 3-phase transformer connected to the 3 SCRs connecting in parallel. Each SCR conduct 120 degree, but we can control this SCR conduction using the firing angle alpha. This circuit we can implement in the MATLAB and also see the result and also measure the values and see the different alpha angle, how can output can be changed. So we see this circuit implemented in the MATLAB. Just I am using the MATLAB 2015. In MATLAB 2015 the power electronics all functions are available, like that SCR, thyristor and diatribe, IGBT, and these different component of power. But we can open this MATLAB, and after opening MATLAB, the SIMULINK library browser, or just type on the command window SIMULINK. After opening the SIMULINK window, here we can see the design circuit diagram in the SIMULINK. Here I am generate one file because the less time for the video, so I am directly explain the how can search this all component. But we need 3 pulse generators for the alpha firing angle alpha control, and the 3-phase programmable voltage source for the 3-phase supply. Here the detailed thyristor, it means SCR. In the MATLAB SIMULINK function, the SCR naming as thyristor. Here the one scope. So here the all outputs are seeing in this window. So how to run this circuit? But after running this circuit, we can search this all components in this window. Here the SIMULINK library browser, and here I am searching just one example giving 3-phase programmable voltage source. For that, here click on enter button. After entering these 3-phase programmable voltage source are searched here, and drag to this window. Drag to in this window. After dragging here, the thyristor we also search in the SIMULINK library. Here just simply type thyristor. So here there are 3 types of thyristor: GTO thyristor, detailed thyristor, GTO, and only thyristor. Here we can choose detailed thyristor or only thyristor. After this selecting thyristor, we can drag into SIMULINK file. Here after dragging, click on this thyristor and disable the show measurement port, because this port is enabled, so output does not see. So this port is so, and copy this thyristor into 3 and naming it to thyristor 1, thyristor 2, thyristor 3. Here I am going to explain the working of 3-phase half-wave controller rectifier, and also the RLC series branch load. This load we can search in the SIMULINK library. In the previous component we can search. Here just type register in this window, register. So here the all registers are saving inductance, capacitance. Just we want whatever we want, just type in this SIMULINK library and enter button. After this enter, we can choose this register or the other components and drag into this window. So after all components are here, here we can see the SCR1 is connected to the alpha 1, means pulse generator 1. Here double click on the pulse generator 1, and here the amplitude of the get pulse is set here. I am I am setting the 1 volt amplitude. Here we can set any amplitude 1, 2, 3, 4, and time period. We can decide the time period on the frequency of input supply. In India, there use a 50 Hz frequency, so 1 upon 50 is 0.02 second, and the pulse width is 5, 6, 7. I am here setting 5, and the phase delay, it means the firing angle alpha. In the MATLAB function, the phase delay means alpha. And how to set alpha? Here the 1 upon 50, the total time period, into the 1 cycle total angle 360, and here I am using the 60 degree 30 degree alpha. So we know that the alpha equation, that the 30 plus alpha to 150 plus alpha. So here 30 degree, 30 plus 30, 60. Now 360 upon 360. Here first alpha we can set after first setting. Similar setting is just 150 plus 30 means second SCR is fired at 180 degree. So this setting is done, and same as the third pulse generator is set the firing angle. Here the 1 upon 50 into 300, because the second SCR conducted up to 270 degree. 270 plus the 30 degree is 300. So third rectifier conducted at 300 to 60 degree. And here the output load. Here we selecting the click on this and search. Select the. I am here selecting the only R load. You can select any load. L load, C load. It means capacitance and inductance. Here RL load means resistive and inductive load. RC means resistive and capacitive. LC means inductive and capacitive. So I am selecting here the R load, and just here we set the R load value. I am here selecting the 500 ohm and just click on OK. Here the scope, we know that the scope is used for the seeing the output. So here the voltage measurement probe, and connected to the connected across the load. Here current measurement. We can care about the current is measured in series. So this current measurement probe connected with series with load, and here observing the 3-phase supply. This 3-phase VI measurement. Just search on this SIMULINK library function 3-phase VI measurement source, and after searching, here we can drag this block into this SIMULINK library. So after implementing these all blocks, just to click on the run button. Here run, and here also set the running time of here I am setting 120 seconds. You can set in 10 seconds, 50 seconds, because this circuit is only run for whatever time here set. After running, click on run button. Here click on the scope display. Here we can see the 3-phase supply, input 3-phase supply. After the first SCR is fired at firing angle within 30 degree, and after the here one function is, so here like that, and all here the first SCR conduct at this yellow gate pulse. Red gate pulse indicate that the second SCR is fired, and the third SCR is fired at the blue pulse. And here the current and voltage. This is the firing angle of 30 degree. So also measure this all input voltage source in tool. include the measure and click on the measure. Here the peak finder signal cursor measurement. You can choose cursor measurement and search. After this, which here we can zoom this waveform. Here we can zoom and seeing that the how the firing angle alpha is changed. So double click on this window. Here we can select the RL load just to stop this first circuit. And after stopping, double click on the R load. And here we choose RL load. Choose low inductor value in that manner. And just after selecting value, click on run button. After run button, here double click on the display, and here we can see the reset button and inductor how can change. No any change because of low inductor value. Here this we can successfully implemented the 3-phase half controller rectifier. So in this circuit diagram, these all blocks are searching in the Simulink library. So thank you.